Okay, so this video is going to cover solving a system by graphing. Okay, so to start off with, when we're solving a system, we're talking about solving more than one equation. So there's three possible solutions that we could be looking for. So when it comes to having two different lines, we can either have the situation where we graph two lines and we see that they meet at this one point, their intersection point. And if that is so, then we're talking about a system that has one solution. Another possibility that we can have is this one here, that we graph the two lines, and after graphing them, we see that they are parallel to each other. And if the two lines are parallel to each other, that means that they will never cross, they will never intersect. Even though they look alike, they share no properties. They share no lines, no points. So that means that that would be a no solution. They have nothing in common other than the fact that they look the same. And then we can have our third case here, where after we end up simplifying or getting our equations in slope-intercept form, we actually end up seeing that the two lines end up being exactly the same. They lay right on top of each other. And if that is the case, then that means that those two lines share every single point. Right? They're the same lines, so they have everything in common. So that is actually an example of infinitely many solutions because they share every point, an infinite amount of points, because we know that line is going to go on and on and on in both directions. Therefore, they will share an infinite number of points. So these are the three different situations that we're looking for when it comes to a graph or solving systems by graphing. So what we need to do is we need to graph both of our lines so that we can see which one of these three is going on. So then in order to graph, we must have it in the proper format, which is slope-intercept form, which looks like y is equal to mx plus b. Because remember, as long as we have it in this form, it makes it that much easier for us to graph it, which means we could then figure out which one of these three situations we have. So our answer will either be 1 point, it will be no solution, or it will be infinitely many solutions. So let's take a look at what we have. So we have this system solved by graphing negative 2x plus 3y equals negative 6. And then we have 2x plus 3y equals 30. So the first thing that we're going to do is put them in the proper format, slope-intercept form. So I'm going to take negative 2x plus 3y is equal to negative 6, and I'm going to solve this for y, which means I need to move that 2x over. So since it's negative, I will be adding it to both sides, giving me 3y is equal to, remember to put the x in front, so we would have 2x minus 6. Then the only other thing we would need to do is get rid of that 3. Remember, that is 3 times y, so we would get rid of it by dividing, making sure that we divide every term by that 3. And let's simplify that. So 3 over 3 cancels, leaving me with y is equal to 2 divided by 3 does not simplify, so we simply have 2/3 x minus 6 divided by 3 is 2. Okay, so I'm going to pause here while we work on putting the other equation in the proper form. So the other equation is 2x plus 3y is equal to 30. So we're going to do the same thing with this one. We're going to get this one solved for y as well. So the first thing I'm going to do is move the x over. Since it's positive, I will be subtracting 2x on either side. Drop down to 3y is equal to negative 2x plus 30. Last step, divide out the coefficient. So divide everything by 3. And we're left with y is equal to a negative 2/3 x. Since that does not simplify, just drop it down, plus, well, 30 divided by 3 is 10. Okay, so I'm left with these two lines here. Y equals 2/3 x minus 2, and y equals negative 2/3 x plus 10. Now that we have them in the proper form, our next step is to plot these onto our graph. Okay, so the first thing that we're going to do then, so the first thing I would recommend when it comes to graphing is always start with your y-intercept. So taking a look at our equation on the left, do keep in mind that as long as we have our equation in slope-intercept form, we know exactly what our y-intercept is here, the -2, and our slope would then be the 2/3. So we would start with plotting the y-intercept. The y-intercept is a -2. That means from my graph, I can go straight down 2 and plot my first point. From that point, we need to look at our slope, and our slope is a 2/3. Now remember, slope is rise over run. So the 2 is how much we're going to go up. The 3 is how much we're going to go over. Also notice that this slope is positive, which means it needs to be going in the positive direction, which from left to right, it would look like it's climbing like this. So back to my y-intercept of a -2, I'm going to go up 2 over 3 and put my next point. Up 2 over 3, up 2 over 3, and connect the dots. That is what the first line would look like. Moving over to the second equation, y equals -2/3 x plus 10. Here we have a y-intercept of a +10, so straight from our origin, we'll go straight up 10 and plot our point there. And then we have a slope of a -2/3, which means we're going up 2 over 3. Okay, so starting with our y-intercept is a +10, so that is right up here at the very top of our grid here. We have a y-intercept of a 10, and from that 10, we will be looking at our slope, and our slope here is a -2/3, which means up 2 over 3, up 2 over 3 in the negative direction. So again, negative direction is going downhill, just like that. So since we don't have much room to go up and to the left, we can do the same and go down and to the right. So down 2 over 3, down 2 over 3 from that y-intercept. So down 2 over 3, down 2 over 3, down 2 over 3, and then we can connect the dots. After we have our lines graphed like we do here, what we need to figure out is which one of those 3 situations we had. Well, it can't be situation 2 because these 2 lines are not parallel to each other. It cannot be situation 3 because these are not the same line. So that means it has to be the first situation where our lines intersect at one point, and we can see that here. These lines do cross at this one point right here. So all we have to do is figure out what is that point. All right, our answer will be the point XY where these 2 lines cross. So if I had to pick out the value of this point here from the origin, it looks like I would have to go over 1, 2, 3, 4, 5, 6, 7, 8, 9 times, and that was in the positive direction. So I have a +9 for my X value. So 1, 2, 3, 4. Okay, so it looks like we have the coordinate 9, 4, which means this would be our solution, which just means this is the one point that these 2 lines share. We can plug this point into both of these equations and get a true solution when we simplify those equations. So they intersect at this one point. This is the one point they have in common. Therefore, this is the solution to our system.